Inductance. Inductance is the property of a conductor to oppose a change in current. The effect of inductance is greatly magnified by forming a coil and by winding the coil on a magnetic material. Lenz's law states that when the current through a coil changes, an induced voltage is created across the coil that always opposes the change in current. This circuit can demonstrate Lenz's law. Initially, when the switch is open, there is no current, or the current is stable through this portion of the circuit. Once you close the switch, now we have a change in current because the total resistance has changed. So the current changes. The inductor senses the oppose and immediately induces a voltage to try to oppose the change. So the voltage that it induces is in this direction because it's opposing the change in current. After a certain amount of time, the current stabilizes at a new higher level and the voltage decays across the coil. So basically the induced voltage reduces to zero. So all that you have left is the winding resistance of the inductor. Factors that affect the inductance are the inductance in henries is equal to the number of turns of the wire, mu, which is the permeability in Webers per ampere turn meters, and L, which is the coil length in meters. What is the inductance of a 2 centimeter long 400 turn coil wrapped on a low carbon steel core that is 0.5 centimeters in diameter? The permeability of low carbon steel is 2.5 times 10 to the minus 4 Webers per ampere turns. So you just plug the numbers in here and come up with 157 microhenries. The only thing that you have to do is calculate A, which is pi r squared. Here is a picture of some practical inductors. You might want to look in your book and take a look at them, as it'll be much bigger picture. Series inductors. When inductors are connected in series, the total inductance is the sum of the individual inductors. So this is back to similar to series resistors. You add the inductors in series, so the capacitors are the only one that are opposite. So if you have a 1.5 millihenry inductor in series with a 680 microhenry inductor, so you're going to take 1.5 plus 680 to get 2.18 millihenries. So on your calculator, 1.5 EE minus 3 plus 680 EE minus 6. Parallel inductors, the total inductance is smaller than the smallest one. So again, it's the 1 over 1 over formula, just like resistors. If you have two, you can also use the product over sums rule. That's only for two, though. Only for two inductors. If you have a 1.5 millihenry inductor connected in parallel with a 680 micro, so you go 1 over 1 over 1.5 milli plus 1 over 680 micro. Inductors in DC circuits. When an inductor is connected in series with a resistor and a DC source, the current change is exponential. So here, once the switch closes, the inductor induces a voltage to oppose the change. So for that instant, when that switch closes, you have the source and an induced voltage on the inductor. The net current is zero. There's theoretically no current flow. And the voltage initially across the inductor is at a peak value. Now as time goes on, the inductor stabilizes the current rises exponentially, and the inductor again goes down to 0 volts. Inductors in DC, the voltage across the inductor exhibits the same type of pattern as the charging voltage on the capacitor, and the resistor voltage always follows what the current is doing. Here we have increasing exponential and decreasing exponential, same percentages. Specific values of current and voltage can be read from the chart. The time constant is equal to L over R, unlike the capacitor where it's R times C. This one's L over R. In AC circuits, the inductor exhibits resistance also, called inductive reactance. It's equal to 2 times pi times the frequency times the inductor value. So a reactance of 33 microhenries, if I have 33 microhenries, frequency 550K, what's X sub L? So that's just 2 pi times 550K for the frequency times 33 micro. That's 114 ohms. When a sine wave is applied to an inductor, there is a phase shift between voltage and current, such that the voltage always leads by 90 degrees. So here, this is the peak voltage. The peak current occurs 90 degrees later. Inductance. The property of an inductor is to oppose a change in current. The effect is greatly reinforced in coils. A fundamental passive component that consists of a coil of wire with specific inductive properties is an inductor. A henry is a unit of inductance. 1 henry is the amount of inductance that induces 1 volt when the current changes at a uniform rate of 1 ampere per second. Inductive reactance is the opposition to AC. Resonant circuit is a frequency selective LC circuit that allows a band of frequencies to be selected from all others. We'll talk more about that in a few weeks.